Hello, welcome to day two, and let's begin. We have three topics today. The first one that we're going to discover is called POS tagging, or it's basically called the part of speech tagging. Okay, so what do we do? It's very similar to what you can understand from this, right? So if I have a sentence like I am, um, yeah, I like pizza, for example, right? So how can you translate this? So you can translate this to I being a noun, like being a verb, pizza being a noun, right? So that's the thing. Like we are tagging everything with its parts of speech. That's the main thing that's our main goal. What we're going to do. Okay. So how to kind of do this? Okay. So for example, like this. Uh, let's say I have some corpus. Okay, corpus will be some amount of text. Let's say Will loves apples. Can Will eat apple? Will Adam eat apple? Will loves Adam. Adam loves apple. Okay, so let's say let it make it apple. So what we have to first find out, we have what we use here is called hidden Markov model. Okay. So in detail, I can't explain hidden Markov models here. I'll link you down a video which you can follow for this. And in hidden Markov models, we have two kinds of tables: emission tables and transition tables. So emission tables tell me ki, what is my how many times any word will appear for that. For example, Adam. Adam noun. Adam is noun 2 by 8 times. Adam is verb 0 by 8 times. And Adam is a modal 0 by half of times. I'm getting how am I getting the half? I'll explain. This will be by 4. So like this you can calculate for each word like will, Adam, loves, eat, and you'll find every probability. Row wise, column wise, you'll find out the probability to be like that. This is my emission table. And transition table tells me what will happen after that. So what will happen with the modal, noun and verb relations. So now with everything we will add a start token at the end, at the first, and we'll have an end token at the first end for all of them. So let's say on this side we'll have start, noun, modal, verb, right? And on this side we'll have noun, modal, verb, end. And now we'll count the probability key after start how many times there is a noun. So after start, if you notice, there are um 3 by 5 times there are nouns. Okay, and after five, 2 by 5 times there will be a modal. Okay, like this you can calculate each of them. I'm not going into detail. Now, for example, in this case, you can now how if I give you a new kind of sentence, right? So let's say will will eat apple. This is a new kind of sentence, and I'm telling you to do POS tagging. Tell me what is the part of speech of each of them. Now you will not be able to do it. Like you can be, the one is a hit and trial method. So we'll say, okay, let everything be noun. Let everything be noun. So that's one possibility. So first, what we'll see, will being noun. What is the probability of will being noun? Probability of will being a noun is, let me check this. Will be a noun is 3 by 8. And noun being after the start is 3 by 5. Okay, plus when is will a verb? Will is a verb in the will is a noun in which case? Will is a noun in 3 by 8 cases. And how many times noun has come after a noun? You'll see noun has come after a noun 0 times. Okay, that will be into them because everything is independent. So like this, he'll go and do everything, and he'll see the probability of this happening is 0, which is not possible, right? So now in this case, you have to do all the possible cases. So it will be 2 to the how much? 2 to the power sorry, 3 to the power 4 possibilities. 81 times you have to check which one has the highest probability and do it. So it's a very bad method, right? So we have something called a Viterbi algorithm. Viterbi, I don't know the spelling. It's Viterbi. Sorry. It's a Viterbi algorithm. So how does this Viterbi algorithm work? Let me try to solve this here. So basically, first word will be start. Always, you know this. And next word will be noun, either noun, modal, or a verb. You know that. So you count all the possibilities from now, start to noun, start to modality, and start to verb. Okay. Now after that, you will see that like what is the sentence? Wait. What is the sentence? Will eat apple. Right. So you'll see N and M have some probability, but verb after a start does not exist. So we will not consider that part at all. So we will not consider this at all. Okay. So we'll not consider this. And now again, the next one can be a noun, modal, or a verb. Okay. When you do the next iteration, noun can either be noun after noun, noun after modal. See the probability. You will see that for this the probability will come to be 0 because noun after a noun or a noun after a modal will not happen. You can see by doing it yourself. So noun case is not there. So I know this will never be a noun. So I'll remove this. So it has to be either modal. So modal after a noun and a modal after a modal. You will notice that modal after a modal can also never happen. So it will be a modal after noun. So this one also not possible. So like this, see, you're getting an optimal thing for each. You get an like if you continue this process, right? You continue this process, you'll see after this the most highest probability will be a verb. And after that, the highest probability will be a noun. And after that, it will become end, of course. Like this, you found out the POS tagging in a very efficient way. This is called a Viterbi algorithm. Okay. So that's the method how we'll do. And so with this, you understand ki the will will eat the apple. In the first will be a modal, as in like will the verb modal, and will second will be a noun. The person will eat will be a verb. Apple will be a noun. So here you can easily do POS tagging. That is the thing that is happening here. This is POS tag. Now let's talk about NER tagging. Okay, so it's a extension of what you have learned in the POS tagging itself. It's basically named entity recognition. Named entity recognition tagging. So basically what we do is basically let's say if I say uh, Mohit went to buy Apple earphones from F FT market, for example, on 7th December. So, mm, see, Mohit is a name, and Apple is a company, earphone is an item, FT market is a location, 7th December is a date. So see here, I am giving some tags to each of them, right? If you notice, I give them some tags. So this is basically give called NER tagging. Now we can, there are many things how to do this. First, you have to do pre-processing to remove all of this. Like remove when to buy, remove from, remove on. Then we get the main stuff. Then first thing we can do is very lookup of data. Basically, this is not that much efficient, but you look up. Like Apple is a company, right? So you see the database of companies and see if Apple is there. If it is there, then it is a company. Or you can also have a rule-based approach, as in like 7th December. So I will say any word after on is always a date, or any word after from is always a location. So these are some rules I'm giving. So these are some rule-based approach. We can also use the Viterbi algorithm, which we just learned in the same manner. Instead of giving them tags of nouns and everything like that, in the place of those tags, if we have these tags of name, company, item, right? And then we use the Viterbi algorithm, we can also do that. So that is the thing. And we can also use many, there are many methods. Like for example, let's say, oh, wait. Let me draw this. That would be better, right? So let's say this is a graph I am plotting. So let's say there will be some points here, some cluster here, some cluster here. So maybe this cluster can be names, this cluster can be companies, something like that. You can easily use clustering algorithms also. There are many ways to do this. So this is something which is readily used in the market, because like Apple, the word Apple can either be a company or either also can be your a fruit, right? So it's important to give them some some tagging to separate the meaning of Apple in both. Or like if I work at Amazon, I went to Amazon. So Amazon here is once a location, once a company, right? So it helps you separate between the both of them. So this is what NER tagging in its essence is. Now we will start something called sentiment analysis. How do you do sentiment analysis? So let's say how to do this. Let's say we will try to separate some positive sentences or negative sentences. You have to tell me if the word has a positive, like the sentence is a positive vibe or a negative vibe. So first what we have to do is we have to find the corpus, right? So let me write a corpus like the most fun film of summer, very powerful. These are the movie reviews, okay? No surprises and very few laughs, entirely predictable, just plain boring. Okay, so these are some things I made, okay? So the first one is obviously positive, second one is positive, next one is negative, next one is negative, next one is negative. So yeah, so these are the sentiments of this film. And now I am writing a sentence called predictable, no fun. You have to tell me, is it a positive sentence or a negative sentence? You can say it is a negative sentence by looking at it, but how will the machine say it? So first you have to see, first you have to make the probability of the positive sentence. How many positive sentences are there? So 2 by 5. And how you have to find the probability of the negative sentences. So that will be 3 by 5. Okay, this is your first thing. Okay. Now we use naive Bayes to solve this. Naive Bayes is based on Bayes theorem. So here we will be trying to find out the probability of W with positive or negative. Is it positive or negative? So how will you find out? This will be just becoming the count of W, W sentiment by sum of count of W sentiment. Normal Bayes theorem. I'm not doing anything different. So count can also be zero. Okay, that's why like sum of count can also be zero, right? We are not having any sentences. So we can have to add some Laplacian smoothing. So we'll just change the formula to here plus 1 and plus the size of the vocabulary. So, yeah. So this will be the formula for us. Now you can find it for every word. So predict what you do. You find out P of predictable, predictable when it is positive. You'll find it out to be 2 by 34, and P of predictable when it is my ignore my spellings. I am really not that great in it. So it will be 1 by 29. So you can find it out. You have to find it out for no. You can do this on your phone, on your own. No and fun yourself, and you'll find out all the probabilities. Okay. Now, what will be the probability of all of them? You have to just multiply them. So you will see probability of P of the sentence plus being plus will be the multiplication of predictable no fun when it is multiplied when it is positive. Okay, I wrote the reverse thing. Sorry. This will be for plus because I have the values right. I'm not solving it right now. I have the values. So when you do this, you'll see it is 2 by 29 to the power 3. And when it is P of the sentence when it is negative, you'll see the value is 4 by 34 to the power 3. Okay, now I have gotten it. Now what you have to find the probability of the sentence in a negative sentiment. Okay, it will be nothing but probability of the negative into the probability of S when it is S when it is negative, right? It comes out to be 6.1 into 10 to the power minus 5. Now probability of when it is positive into the probability of when it is the sentence will be positive comes out to be 3.2 into 10 to the power minus 5. So it see you will see that the negative probability is bigger. No, so that means this sentence will be predictable. No fun will be an um positive means a negative sentiment sentence, and that is what we found out. No, so yeah, so yeah, since it's like that, you can find out to you can do something ki we can do it for more words, like more sentiments like happy, sad, angry, moody, something like that. So this is for just two, so this is a binary um, case. So you can try it like this. So this is with this we end our day today with sentiment analysis. You can try projects like this for fun. There is some data set called ham or spam. You can do the same on this. You'll find you'll get around 99.1% accuracy on naive base, which I have taught you right now.